Okie dokie. The key for these last two sections, the application sections, those are word problems. And the key is, if you look, we've got 1, 2, 3, 4 different types in 510 and 2 different types in 511. But if you just keep going to the next problem, you're going to feel like there's a million different types. So the best suggestion I can give you when you're doing your practice is to stick with one type, click on get your answer, click on try similar, do it that same type 3 or 4 times before you move on to the next problem. Okay, that's your best way to learn the word problems is to stick with one type, repeat it until you can do it with your eyes closed, then go to the next. Okay, so this is what we call a number problem. The key to word problems is to read carefully, and I like to say start at the end. So I need to understand what I'm looking for. I'm looking to find the two numbers. All right, I need to know what sum means. Sum means addition. So the sum of two numbers is 13, and the sum of the smaller and 6 times the larger is 48. So here's one equation, and here's my second equation. So for Unit 5, my variables, I'm going to let x be the larger number and y be the smaller number. So one equation is that the sum of those two numbers is 13. And then the second equation is the sum of the smaller and, so the smaller is y, smaller and 6 times the larger is 48. So there's my two equations. So I can now solve this with substitution or addition, either way. Usually, most of my students find that substitution is the easiest way to solve these, but it's up to you. If I rewrite the second equation, let me write the first one again, and rewrite the second in the order that the first one is, in other words, x first and then y, I notice that if I multiply the second equation or the first one by -1, my y's are going to cancel out. It'll be -6x. I'm doing -y. I'm doing addition here just because it seemed really easy to me. Those cancel out. -6 and 1 is -5. -48 and 13 is -35. Divide by -5, x equals 7. So then I can go back to either of these two original equations. 7 plus y is 13. I'm choosing the first one to substitute that x equals 7 into. So subtract 7 from both sides, and y is 6. Hopefully that makes sense. I solved it using addition. You could also solve it using substitution. So the larger is 7 and the smaller is 6. Now again, I want to remind you before you click on next, if this was you doing this at home, you're going to try similar and you're going to do 3 or 4 of these problems that look exactly the same except for the numbers are different. And really just drill one type of problem before you click on next. So that was a number problem. Now we've got an age problem. No, not helpful. All right. So again, you're going to let one of these things be x and one be y. And this is, recognize that this is now, but we're also going to talk about in 3 years. So in 3 years, and the other thing I like to do, let's do this instead of x and y. For these age problems, it's going to help me to just use G for Greg and L for Linda. And that way, when I get my answer, it's going to be easier for me to remember whose age I just found. So this is, so this is now. So now Greg is 22 years older than Linda. So Greg is Linda plus 22. In 3 years, Greg will be Greg plus 3 and Linda will be Linda plus 3. Okay. So in 3 years, so Greg plus 3 will be twice as old as Linda. So Greg plus 3 will be twice the age as Linda plus 3. So those are my two equations. This guy is already set up for substitution, so I'm going to substitute him into here. So I'm going to have, instead of G, I have L plus 22 plus 3 equals, and I can distribute this to L plus 6. Take away L from both sides. Combine these like terms. Minus 6. So Linda right now is 19. And Greg is 19 plus 22. That's a big age difference. Let's see, that's 41. 19. Yep. So 41 and 19. All right, here we have distance, rate, and time. Stacy travels 4 times as fast as Carol. So Stacy's rate of travel, let's call that S. Carol's is C. Stacy travels 4 times as fast as Carol. So Stacy is 4 times as fast as Carol. Traveling in opposite directions. So I need a little diagram here. They're starting here and they're going in opposite directions. Let's say Stacy's going this way, Carol's going this way. They are 300 miles apart. So their total distance is 300 miles apart after the time is 7.5 hours for both of them. So I call this the DIRT formula because distance equals rate times time. Sort of looks like the word dirt. So I need a distance for Stacy plus the distance for Carol is going to add up to $300 miles. So, and distance is rate times time. Well, time is 7.5 for both of them. And Stacy's rate is S and Carol's rate is C. So the distance for Stacy is 7.5, her time times her rate. And the distance for Carol is the time times her rate. So there's one equation, and here's the other equation. So we're set up for substitution really nicely. We're just going to substitute this one into this one. So 7.5S instead of S, I'm going to write 4C plus 7.5C is 300. 7.5 times 4 is 30. 30C plus 7.5C. So 37.5C is 300. Divide both sides by 37.5. And Carol's going 8 miles an hour. All right, Stacy is, we're going to plug that back into here. Stacy is 4 times Carol. So Stacy's going 32 miles an hour. 32 and 8. The hardest thing about these problems is setting up your equations. So you're going to need a lot of practice. I've been doing this a million years, so I can do it fast and easy. It's going to take you a long time, so don't be discouraged. I'm not going to do this one because it's another number problem. I'm going to skip and try to find another. This one looks harder. This is a different one. A different one for us to do. If I can get my screenwriter to come on. Hello. Okay, that seems to be working now. All right, so when I've got shapes, I think it's helpful to draw them. I can't tell if this is recording or not. I think it is. Sorry, hopefully. Okie dokie. So I've got a square and a regular hexagon, and it tells you that a regular hexagon is a 6-sided figure. Sides are equal length. So my square is going to look like this. Each side is S. And my hexagon, 1, 2, 3, 4, 5, 6, is going to look like this. That's an H on top. I realized I was writing on the words. Tried to change that. All right. One side of the square one side of the square, S, is 29 feet longer than a side of the hexagon. So a hexagon side plus 29. There's one equation. The two figures have the same perimeter. So the perimeter of a square is 4 times the length of a side. The perimeter of a hexagon is 6 times the length of the side. And we're told that those are the same. So our equation here is that 4S equals 6H. There's our second equation. So let's substitute this guy into here. So S is H plus 29. So I'm going to have 4H plus 29 equals 6H. Distribute 4H plus 4 times 29, 116 equals 6H. Minus 4H from both sides and divide by 2. So that's the hexagon, so that's going to go here is 58. And then I can plug that back into here to get the side of the square. 58 plus 29. 8, 9 is 17, 5, 6, 7, 87. Let me just check that. 58 plus 29, 87. Yep, so 87 and 58. Okay. All right, a distance, rate, and time problem again. So I need to think about what I've got going on here. I'm going to draw a diagram to help me. I've got 2 buses. So I've got bus 1. It goes at 55 miles an hour. And bus 2 goes at 56 miles an hour. 1 mile an hour difference. How soon? So that's time that I'm looking for. Will they be 610.5 miles apart? So they're going to leave the same place at the same time, traveling in opposite directions. So it's going to look like this. And the bus number 1 goes at 55 miles an hour. Bus number 2 goes at 56 miles an hour. Their total distance apart is going to be 610.5. So the distance bus number 1 goes plus the distance bus number 2 goes has to add up to 610.5. Distance equals rate times time. Okay, time is what we don't know. So we're just going to I'll use a capital T since I'm using capital letters for the others. So the distance bus number 1 goes is his rate times his time. The distance bus number 2 goes is his rate times his time, and that has to add up to 610. So 55 and 56 is 111. So T is 610.5 divided by 111. 5.5. So in 5.5 hours, that's when they will be 610.5 miles apart. All right, I think we have time for one more. This is another distance, rate, time problem. 2 planes took off from the same place. They're going in the same direction. So their little diagram is going to look like this. Okay. The first plane is traveling 2.5 times as fast as the second plane. So let's let the second plane be X. And this guy is going 2.5 times as fast. So there's our substitution we did right there without even thinking about it. So let's say this guy's going to get further. So his speed is X and his speed is, sorry. The slower guy is X. The first plane is on the bottom, 2.5 times as fast as the second plane. All right, after traveling in the same direction, so their time equals 7.5 hours. They are 1,035 miles apart. So that's 1035. So that means that the distance this guy goes minus the distance this guy goes